Hello class, and welcome to lesson 7.6, applications using similar triangles. So ladies and gentlemen, there are things in life like buildings, heights of trees. For example, say you want to try and find the height of a tree. It's pretty hard to climb up right to the very tip without bending those branches out. So what we do is use things called similar triangles to help us measure that out. So a simple solution would be to find the height of the tree outside. If you just look out your window and look out at a tree, would be if the sun's shining, folks, you could measure the shadow of it and then take a measuring stick, put it vertical into the ground and find the shadow of that. And since you've got the measurement of a meter stick and the shadow measurement, you could compare it to the shadow of the tree to find the height of the tree. Okay, so we'll go over a couple examples where you're going to see this in the real world. And we're actually going to do that example when I talked about the shadows of the tree. So we'll do that if that didn't make sense. We're going to do that in our lesson today. All right, so before we get going, folks, sometimes a mathematical question might be to say, prove that two triangles are similar. Okay, so if we're going to develop a proof, we first of all have to say in the two triangles. So you do an intro statement, which is in triangle LMN and triangle LQR. Notice I don't have any symbols in there yet because I have to prove it first. And then in my concluding statement, I will put that they are together. Okay, so taking a look, we've got to remember what we notice about, parallel lines. Okay, so you might remember things like F pattern, Z pattern, C pattern. We're going to use the F pattern today. So I'm going to start with this angle right here. Okay, so I'll use my big triangle first, and I'll go angle NLM, okay, equals, and I'm going to compare it to the smaller triangle, which is RLQ. Okay, and why do they equal? Because guess what? They're the same angle. Okay, so same angle. Okay, now we're going to use the parallel line theorems to help us figure out the other ones. Okay, so let's take a look at comparing this angle, for example. Okay, so if I go LMN, so angle LMN, that equals the same angle but in the smaller triangle, which is angle LQR. Okay, and that's from parallel line theorem dash F pattern. So it's an upside down F. If you're wondering where the F's coming from, if I highlight the first angle and then I highlight the second angle, notice it's a backwards upside down F. Okay? And again, if two triangles are the same, then guess what? If two angles are the same, therefore the third triangle is the same. But what we have to specify is that not all sides are the same. So what measurements have sides? We're going to say note that I'm taking a look at my base, for example. MN does not equal. That's a does not equal. You take the equal sign, folks, and you put a line through it. Okay, that means does not equal QR. That tells me that it's not, and they're not congruent triangles. Okay, all right. So therefore, now we've got it proved that, hey, we've got these two angles the same, which means the third one has to be the same, and we know that at least one triangle side length is not the same. So then we can say, therefore, triangle LMN is similar, that's your tilde, to triangle LQR, and because it's angle-angle similarity, okay, because we've got the two angles. Awesome. Now we have to do part 2. Now we have to solve for X and Y, and these are some tricky ones. I don't know if last night's homework you ran into some tricky ones, but these are kind of tricky. So let's do our proportional ratio setup. So over here I'm going to go LM over LQ, so do the bigger triangle on top, equals MN, which is my base, over QR, and the last side we'll do LN over LR. Okay, so let's fill in the information that we know. Okay, you've got to be careful when you do LM. Okay, for example, LQ is easy. LQ, we know, folks, is 3.1, but Y is just the distance from here to here. So in order to do the complete distance, it's Y plus 3.1. That's a tricky one. Okay, I'm glad we're doing this in the warm-ups together. Okay, and MN has 6.9, QR is 2.3, LN is, again, one of those tricky ones. To get from L all the way to N, it's X plus 2. Okay, and on the bottom, which is LR, is just X. So notice, ladies and gentlemen, just like last day's lesson, we have one ratio that has the values in it. So to find Y, we're going to go like this first. So we're going to find Y. And it's a little harder this time because we've got some variables and constant that needs to get multiplied. So I'm just going to rewrite this out because it's a little tricky. Okay, so I'm going to write my ratios together. So Y plus 3.1 divided by 3.1 equals 6.9 divided by 2.3. Cross multiply. You got to be careful when you cross multiply this time. Okay, because it's 2.3 times this whole thing. So that's why you're actually going to use distributive law here in a minute. Okay, equals the other cross, which you can do in your calculator, folks, which is 21.39. Okay, remember distributive law, guys, you got to multiply whatever's in front of the brackets by everything in the brackets. So we're going to have 2.3y plus, use your calculator there, folks, and you're going to get 7.13 equals 21.39. Okay, we want to leave the constant term where, we want to leave the variable term where it is, which is 2.3y. We're going to bring this constant term over and subtract it on the other side. Again, you're going to need your calculators here, folks. So we're going to get 2.3y equals 14.26. And to get y by itself, you divide by the coefficient, which is 2.3. So y, ladies and gentlemen, equals 6.2 centimeters. So there's y. Okay, we found y. Now what we need to do is find x. So to find x, ladies and gentlemen, I'm going to use our ratio that we know, okay, and the ratio or the fraction that the equation that, sorry, back up the truck there, the fraction that has x in it. So I'm going to write this out. So to find x, okay, I'm going to use 6.9 over 2.3 equals x plus 2 divided by x. Now, this may look a little strange, might be a little harder. However, when you cross multiply, you're just going to have two variables with x in it, okay? So let's do this. So I'll start with this one. So 6.9 times x is 6.9x, okay? Okay, and then we do the other cross, ladies and gentlemen, which is 2.3 times x plus 2. Okay, so taking a look, ladies and gentlemen, we're going to use distributive law, multiply that through. So we have, wrong color, 6.9x equals 2.3x plus 4.6. Okay, this time we got to collect our variable terms. So we're going to take this one and bring it over and subtract. So 6.9x subtract 2.3x equals 4.6. Okay, subtract those, ladies and gentlemen. You're going to have 4.6x equals 4.6. Hey, how do we get x by itself? Divide both by 4.6. So x equals 1, and what are our units here? Centimeters. Okay? Awesome. So that's a tricky one, ladies and gentlemen. So just be careful of those, especially when the measurement, you got to watch carefully when you look at what the x and the y is. So remember, y is just that value, which isn't in a complete triangle. Same with x. X here is in a complete triangle, okay? But in order to do ln, you had to use have x in both the numerator and the denominator of a fraction. So that's just the warm-up. Woohoo! Now we're going to take a look at our applications today, folks. You don't necessarily need to write these steps down because they should be very familiar to you. Read a question, create a diagram that contains two or more triangles, write a let statement, prove similarity or do a mental check of the triangles. Use proportional ratios to solve the problem, and then concluding statement, and that means to include your units. So therefore, the height of the tree or the length of the river, or whatever we're taking a look at, make sure you have your units in centimeters or inches or feet, kilometers, etc. All right, example 1. Okay, and we're going to do 2 examples here today. Example 1, your task is to determine the height of a tree using shadows from the sun. Okay, so we're going to start off with the ground. Okay, so on the ground, it says that a measure stick is standing perpendicular. So here's my my meter stick. And folks, here's the hardest part. A meter stick. What's the height of a meter stick? It's 1 meter. So many people get stuck on that. Please don't be the one that gets stuck on that. Okay? It's standing perpendicular to the ground, creates a shadow of 0.8. So I'm going to create a triangle here, folks. Okay, and it's going to be 90 degrees, and the shadow is going to be 0.8 meters. Okay, at the same time, the shadow from a tree, so a tree is going to be much bigger. So shall I be artistic, folks, and do my nice little tree here? Let's see. Maybe it's festive. Maybe it's like Christmas time. Here we go. Okay, so we don't know the height of the tree. Okay, but we know that when we create a triangle, guys, that it casts a shadow that is 14.6 meters. Okay, so you can choose to let whatever we need to find the height of the tree. So calculate the height of the tree. So you can choose to let X or H. I'm going to put X for my height, and don't forget your let statement. So let X represent the height of the tree, or tree height, if you want to put down that. Tree height. Okay, and I'm just going to throw on my units here, meters, in case I forget. So what we need to do is, folks, take a look here. Visually, do we have a similar triangle? How can we tell? We both have 290 degrees. They're both perpendicular onto the ground. We assume that. And the angle forms the same angle with the sun. So we know we've got 290s, and we've got 2 angles here from the sun. They have the same value, so that would prove that they are similar. Okay, so all you do is say, okay, shadow of the meter stick is 0.8 divided by the shadow of the tree, which is 4.6, equals the height of the meter stick, which is 1, divided by X. Cross multiply here, 0.8x equals 14.6, divide both sides by 0.8, and X equals 18.3 meters. I can't imagine myself climbing a tree 18.3 meters and getting right to the very top, okay? Although I was a monkey when I was a kid, I still can't handle that. And last step, folks, in your problem, to make sure you have a therefore statement. So therefore, the tree height is 18.3 meters. Okay? Awesome. So there's one problem. We got 1 down, 1 left to go. Let's do this one. Okay? Surveyors. Surveyors use similar triangles all the time. So if that's a job you're thinking about, guess what? You use it all the time. Okay, so surveyors use similar triangles to calculate measurements that are hard to measure using a measuring tape. So to calculate the distance across the river, so this is what we're trying to find right here. Okay? Surveyors set up the following diagram. Okay? So let's first of all put X down, and let's say let X represent river distance. Okay, so they set up the following diagram. So what they did is they said from a focal point we're going to measure 22 meters. And if you ever see surveyors out, they have these sticks with these holes in them. So someone would stand here with a stick, make sure that in the same line of sight they would have this point here that I'm highlighting and this point here. Okay, and then what they would be able to do is another person would get here with a stick and make sure they've got those 2 lines of sight, meaning this pole, and then they would take measurements from their poles. Okay, so that's what surveyors kind of do. They mark things and put measurements in. So taking all this diagram, folks, hopefully you realize that with this being a 90-degree angle and this being a 90-degree angle, we got one angle that's the same. Remember that when you intersect two lines, those are what's called opposite angles, or opposite angle theorem. So I know we have at least two angles that are the same, so that proves that we got similarity. So all we have to do is figure out how to match this up. Okay? So what we want to take a look at is x. X over what side, folks? You got to be careful here. You got to make sure that it's the same distance measurement. So x over 12 equals 22 over 8. Make sure you got your biggest measurements on top and your smaller measurements on the bottom in terms of triangles. Cross multiply. So 8x equals 12 times 22, which is 264. To get x by itself, you divide both sides by 8. So x equals 33. So therefore, the river is 33 meters wide. Okay? Awesome. So again, surveyors use this, construction, a lot of people who, if you're doing geography or maps, that's what you do. All right, here's your homework, guys. Page 679, numbers 4 to 11. Make sure for each example that you draw a triangle, let statement, show your work, therefore statement, and have fun with it. This is real life stuff. Okay, have a great day, guys. Namaste.